So I actually came up with this topology here yesterday. It's just a real simple topology to use, considering the devices I have. So this is what I'm going to do. In the real world, hosts like your laptop, your PC, connect to switches. So I'll put a switch right here. And web servers probably connect to switches as well. So I'll put a switch right here. And in the real world, I would probably have lots of hosts. Let's imagine all these circles are hosts connecting into the switch, and I might need more than one. Or I might have, a switch on one floor connecting to a switch on another floor. So to try to simulate like a real world environment, let's just put a second switch here. And then that switch is going to connect to a router. And maybe all of this is in one building. So we'll just say here, building 1. So let's just say this is my laptop. And we'll call this switch 1. We'll call this guy switch 2. We'll call this guy router 1. And this guy over here will be switch 3. Now, if this over here was in a different building, which it probably is, right? I mean, most likely the location of the web server is not in the same building as me. It's probably several states or several countries away. Well, then we're going to need a router over here. So I'll call this guy router 2. And we're going to have some, in the real world, some sort of WAN, wide area network. All right, now this might be provided as like your cable modem or your DSL connection or maybe Metro Ethernet. But one building is going to need to connect to a service provider. That's your WAN provider. Another building, a few states or miles or countries away is going to connect to a service provider. And that service provider will provide your connections. And that's usually, I'm going to use serial connections here. So what is a serial connection? It's just a different type of port. For example, if I zoom in right here to this, all right, so this, notice how it says FE right there? That stands for Fast Ethernet. This type of an interface is called an Ethernet interface. What is Ethernet? Well, we know that ultimately, what's going to happen here? We're going to plug a cable into this. And why are we plugging a cable into this? Well, because we're going to have electrical energy come in and out of that cable, right? The whole idea is, when I say that I'm sending a packet, an IP packet from my laptop to a server, or from the server to me, what is an IP packet fundamentally? It's a bunch of data, right? Well, what is the data? It's energy, right? It's energy that's representing what I've typed. It's energy representing a picture or a movie or a sound file. So that energy has to flow across something. If we're talking about electrical energy, it's flowing across a cable. So there are certain protocols that say, how do you do that? For example, how do you, when the energy is flowing across the cable, who can talk? In other words, can two devices connect that cable talk at the same time? Or the rules say that only one person can talk and then the other person can talk? The protocol dictates that. The protocol dictates how strong does this energy need to be, right? Do I need a battery the size of a refrigerator to power this cable, or do I need a tiny little battery to do it? Different protocols have different rules for that. Some protocols say, okay, once I put something on the cable, how far can that energy go so that the device at the other end can recognize it as being legitimate data, as opposed to just being random electrical garbage that doesn't mean anything. So Ethernet is one type of a protocol that defines that stuff. Ethernet defines, okay, how long can the cable be? How many wires should be inside of it? What's the energy going to look like when it pops in or pops out of this interface to be recognizable as data? Now, Ethernet, as one example of a protocol, is used in local area networks when we're connecting things that are fairly close together. Like, for example, in your office or in your building or on your floor, connecting one computer to another, or connecting a switch to a router. Things are fairly close. So this is what we call a LAN, a local area network interface. But when I want to connect across vast distances, for example, if I want to connect my router to my service provider, who's a few miles away, they might not support Ethernet. That's where another kind of interface comes into play. This is called a serial interface right here. And notice, in addition to the name being different, Ethernet versus serial, there's some tangible differences. You can see the form factor is totally different. It's going to use a lot more pins, a lot more wires than Ethernet. The cabling is going to look different. How it actually deals with electrical energy is going to be different than Ethernet. So just to give some variation here in my topology, what I'm going to do is I'm going to connect like this. So let's put my laptop over here. All right, so my laptop has a network interface card that supports Ethernet, and that's going to connect to, let's just say, port number 1 on this switch. And then I'm going to take the last port here, connect it to the last port of this switch. All right, so that's my laptop going to switch 1 to switch 2. Switch 2 then is going to connect to an Ethernet port on my router. So that's router 1. Okay. Actually, this router doesn't have a serial interface, so that's not going to work. Hold on just a second there. So we'll have this. Let me just make that a little bit more elegant there so you can sort of follow the line. So we'll have this come along and go right, boop, right there into that. Okay, so this right here, so my laptop, switch 1, we'll just say switch 1 right here, switch 2 right here, and router 1 right here. That represents all the devices in my building number 1. And then we're pretending that there's a space of miles between router 1 and router 2. So even though they're actually, physically located right next to each other, let's just imagine that they're separated by miles, and so I have a serial connection connecting them both together. So we're just imagining that my service provider is like in the middle right here. All right, so that's router number 2. And then he's going to connect to a switch. Okay, so right there. And then he's going to connect to this other router, which is acting as my web server. Because remember, I said that Cisco iOS has a web server built into it. So imagine that instead of this being a router, this is actually like a server, a web server. So that's how I'm going to connect things together. So knowing that, this defines now how my octal cable connects out. I'm going to say, all right, well, I'm going to put octal cable number 1 right here, octal cable number 2 right here, and we'll have number 3 right here, because that all represents building number 1. And we'll have octal connection 4 right there. We'll have octal connection 5 right there. And then my 6th console connection on the octal cable will be right there. So let me go ahead and connect up my octal cable to do that. So right now you can't see me, but I'm plugging this into the interfaces of my terminal server. So I'm plugging that long. So right now I'm connecting this right here. I'm connecting one end of that octal cable to this. I just did that. Hopefully it's nice and tight. And now I'm going to look at the other ends that have RJ45 on them and see how they're labeled. All right, let's find number 1. Where is number 1? All right, so here's number 1. So I'm going to plug that into my switch on the bottom. Okay. All right, that's plugged in there. Number 2 will plug into another switch. Okay. And my project editor will just edit all of this stuff in the recording, so I'm sure it's boring the daylights out of you guys, but hey, we did say we connect something from the ground up, right? So this is part of that process. And number 3 will go into router 1 on the top there. All right. So you see, by designing my network, it helps me to connect my octal cable in a way that's logical, that makes sense to me. And number 4 goes into that router, who's second from the top. Okay, and then number 5 goes into that switch there. Okay, and lastly, number 6 goes into the router, which is going to be acting as my terminal server. Right there. All right, let's power all these guys on. That some routers and switches have the USB port as like, you can have a USB key as like an extra security feature, where even if someone's connected to the console port, if a USB key is not plugged in, they can't get access to the console port. Other routers and switches, you can plug in a USB like memory stick, and you could use that as an additional memory source for like storing Cisco iOS software images and stuff. Specifically on this equipment, I'm not sure what that USB port is used for. Sometimes it's not even active. Sometimes it's there and it's just not turned on by the hardware manufacturer. All right, great. So let's go ahead and now connect. So let's go ahead and so right now all my console ports are connected. So I'm going to go ahead and go into Secure CRT. Okay, so what you're seeing here is the Cisco iOS command line. This router has already been this terminal server has already been pre-configured with a name called Access Server. What I just typed in right there. So where I'm at right now, so Cisco iOS, and I'm not going to go into a lot of details of this because I go into this in my CCNA videos. But Cisco iOS has, let's see here, hold on, I'm just looking for a certain button that I'm looking for here. There we go. Cisco iOS has different modes or levels of configuration. For example, this right here, not that, but this right there. The fact that you see that says Access Server and then that, the greater than sign, tells me what mode I'm in. That tells me I'm in exec mode. And in exec mode, I can't really do much of anything. So I want to get to the next mode, and I type in the command for that, which is enable. And now you can see that the sign has changed to a hash sign, and that tells me I'm in what's called privileged exec mode. From here, I can actually have access to configuring the device, monitoring device. I can do a lot more stuff. Now to actually configure it, I need to go into another mode, which is called configuration mode. Configure terminal. And that gets me into configuration mode. Now if I get out here for a second, if I look at the configuration, you'll see one of the commands in here, come on, is the hostname command, right there. That's why this thing says Access Server, because before the show started, I got in here and I typed in hostname access-server. Otherwise, by default, it would just say router. Okay. And here's how I've set up the octal cable. So in order for this to work, the access server, number one, has to have an IP address. Now, where did I put that IP address? Let's go ahead and I'll show you a little bit more here. Show run. Now, remember that I said that any interface on a router or switch, let's just talk about routers for a moment here. So these routers. So this interface here needs an IP address. This interface here needs an IP address. This serial interface needs an IP address. These interfaces, think of it like this way. Think of let's go right back to postal addresses again, home addresses. So think about your street, right? Your street has a name. Let's say Elm Street. So Elm Street would be like the network. Would you ever send a letter to Elm Street? No, because you're not going to send a letter to the street. That's just concrete and asphalt, right? You're going to send a letter to some location on that street. So your house might be 1 Elm Street. Your next door neighbor might be 2 Elm Street. So a network has a bunch of IP addresses on it. All those IP addresses have something in common, which is like the name of the street. So for example, if this is my cable, I might say, okay, everybody on this cable is going to have an IP address beginning with 10. So PC number 1 here might be 10.1.1.1. PC number 2 might be 10.1.1.2. But all the devices, whether they be PCs or laptops or servers, are going to have an IP address because they all connect to this network. And because they're connecting to the same network, what they have in common is the name of the network, which is 10, and then a unique identifier like 1 Elm Street, 2 Elm Street, 3 Elm Street. Well, in this particular case, Elm Street's coming at the end. That's what they all have in common. And what's unique is their individual street addresses on Elm Street. Here with IP addresses, the name of the street comes first. The name of the network comes first, which in this case is 10. And then I've got 112, which is a laptop. 113, which is a laptop. So just like a laptop or a PC is a unique entity on a particular network, and so it needs to have the address of that network and its own unique identifier on that network. Similarly, on a router, every interface on a router is like a unique entity on a network, right? For example, when you think about your laptop, right? Here's my laptop. Well, what is your laptop really? It's a whole bunch of components put together, right? You've got your monitor right there. You've got some keyboard right here. Okay. Well, the IP address, in order to give this laptop an IP address, you got to put it somewhere. You don't put it on your monitor. You don't put it on your keyboard. Those things aren't connected to the network. What is connected to the network? Well, you have a special card in your laptop called a network interface card. A NIC. So if you actually look, like I can't lift up my laptop right now, but if I was able to lift up my laptop and show you, you'd see it has an RJ45 port in it, just like these routers have an RJ45 port. That RJ45 port is connected to a network interface card, a specific component of my laptop. That network interface card is what needs the IP address. And we'll see as I build up this network, I'm going to have to give my laptop an IP address so it can talk to the network. We'll talk about that. Well, guess what? There's a network interface card right here in the router. Just like my laptop has a network interface card, the router's interface has a network interface card. Just like my laptop needs an IP address because his NIC is a unique host on the network, this right here is a unique host on the network. It just so happens that while a laptop just has a single NIC, a router can have multiple NICs because it connects to multiple networks. Your laptop just sits on one network, like the 10 network. Whereas this router, this interface might connect to the 10 network, this interface might connect to the 99 network, the serial interface might connect to the 200 network. So right now this router has the ability to connect to 3 different networks. So I'm eventually going to have to configure IP addresses on these router interfaces. Well, what does that have to do down here with my terminal server? In order to send information out the async, line to a console port, I have to provide a configuration in the router, which looks like this, the IP host command. And the components of the IP host command are like this. Actually, just do this right here. Okay, there we go. So IP host, and then the next thing right here is going to be just a descriptive name. Like in my case, I'm going to call it switch 1, switch 2, but you could call it anything, right? You could call it building 1 router, building 3 router, but you're going to have some sort of descriptive name. Followed by the line number. Oops, that's way too high there. Line number. Now, what is that line number? Remember when I showed you that octal cable, how it was labeled like 1, 2, 3, 4 at the end of each one? That's what this line number is. So for example, 2001 is terminating at octal cable number 1. 2002 is octal cable number 2. And then lastly, you need to provide it an IP address. Not going to get into a lot of details as to why. What you can do is you can research, if you want to find out, go to Google and type in these search terms. Type in reverse telnet, so reverse like going in reverse telnet octal cable, octal like OCTAL. So we're using something called reverse telnet here, and reverse telnet requires an IP address, and that's all I'm going to get in because that gets a little bit complicated. So this terminal server needs an IP address. Well, where's it getting it from? I could have put it, so if I go back to my image here, so the terminal server itself, which is this guy right here, actually has some networking interfaces. I could put an IP address on this right here, on this right here, or on this right here. He also can connect to 3 different networks. And then I could have referenced that IP address as part of my IP host command. Instead, I'm putting the IP address on what's called a logical interface, which is called a loopback interface. Now right there, that might be something new. Logical interface, what does that mean? Up until now, what I've been showing you has been physical interfaces. In other words, interfaces that you can actually plug a cable directly into that interface. A logical interface is an interface that you just make up from scratch that doesn't exist, which is just sort of like a placeholder for an IP address. Why do I want to do that? Well, let's think about this. Let's say that theoretically, I put an IP address on this physical serial interface. All right, maybe that's where I put my 100.111 address. So that's where it sits. 100.111, and I configure it on this interface right here. Okay, and then I start putting my IP host commands, which allows me to connect to the console port of this router right here, or the console port of this one, or the console port of this one right here. Here's the problem. If something happened to this interface, if it went down, like if I yanked the cable out of this interface or I disabled the interface, now those IP host commands, they wouldn't work. I wouldn't be able to use my octal cable now to get into the console ports of the various devices because it needs, that IP host command needs those IP addresses to be up and functional so the octal cable will work. So if I put if the IP address it's referencing is on a physical interface and something happens to that physical interface, now I've lost my ability to get into the console ports of my various devices. That octal cable is useless to me. But I can create a logical interface, in this case called a loopback interface, and a loopback interface is not dependent on a cable. A loopback interface, because I create it from scratch, this interface will always be up as long as my terminal server is up. As long as my terminal server is up and functional, this loopback will be up and functional, and this IP address will be up and functional. So it's a much more stable IP address that I can reference in my IP host commands. So now that I've configured my IP host commands referencing this IP address, how do I actually get into like the console port of, let's say, well, let's start here. Let's start with switch 1. Well, I just called it S. I know that switch 1 is connected to my first octal cable, and I've just given it a descriptive name of S1, so I just type in S1, I hit enter, and now I'm in the switch. I can go back to the terminal server, and I can type S2 to get into one of the other devices. So now, instead of having to plug and unplug things into the console ports, I can just go back and forth between my terminal server and getting into those devices by virtue of the fact that I configure these IP host commands. So I'm going to go ahead and stop this recording right here. So at this point, I have explained what a terminal server is, I have explained what an octal cable is and how everything's connected in, and I've explained the basics of what I need to configure on the terminal server to be able to use that octal cable.